equations again. And this time I'll just do it like this: minus 4x plus 2y equals negative 14. And I'd like you to solve for y, please.
For the first one or the second one?
This is just the general form up here at the top. There's nothing to do there. You can just call it general form if you want, but this is the example. This is the one I want you to work through on the second line.
Okay. Okay.
Do you have your final? You got your final answer for me?
Yep.
All right. So can you read it out loud?
Yep. Y equals negative 7 plus 2x.
Okay. So let me just work through this problem on the left here, just in case you want to look at it later. Now, my preference, and this is something that I want you to do, and I can try to explain why if needed, but I like to put the x term in front of the number, the constant. And there's a reason for that we'll learn later in our lessons or studies together. So it is 2x minus 7, or like you said, minus 7 plus 2x, but this is sort of preferred. Okay, so one more problem here. This time I want you to solve for x. So we'll go minus 3x minus 9y equals 12. So I'd like you to solve for x in this one. And then we'll move to a new question.
Okay. All right, so I got x equals negative 3y plus negative 4.
Okay, so let me work through that here. I'm going to add 9y to both sides. And I mentioned that in the previous problem, you would want to put the letter first. It's just sort of preference. Divide both by negative 3. And like you said, it's minus 3y minus 4. Good. Okay. So so I do have my question of the week that I will show you here shortly. But before I show you the actual question, I want us to look at the answer space together. This is an important skill to look at here. So when you look at this answer space, and I'll post the question here, or put the question on the screen here shortly. Well, tell me some of the things you notice about the answers here, and you're looking for things that are the same, that are different. You're looking at the format of the answers. Can you tell me anything that you notice here? Anything that stands out to you?
Some have negatives, some don't, and they're all 6. Have a denominator 16.
Okay, they're all fractions also, which means whatever we're doing means we're going to be manipulating those kinds of numbers. Are you comfortable adding and subtracting fractions?
I think so.
All right, so let me just give you a quick question just to see where you're at on this. I would like you to simplify 1/8 minus 1/2. And I want you to do it quickly if you can.
So -3/8.
Okay, very good. Let's try another one here. How about 1/81 minus 5/27? I'm sorry, 5 over, I didn't make this right. Sorry, 5/9.
Okay. -44/81.
All right, very good. Okay, so we're gonna look at something else now that I want to see what your comfort level is. If I asked you, like, what is 2 to the power of 6, can you tell me that quickly?
Yes. So let me just write it down.
Sure.
So 2, 2, 2, 2, 2, 2. So 4, 8, 16, 18, 64.
It is 64 for sure. What is 2 to the 5th?
32.
Okay. How about 2 to the 7th?
128.
Yes, very good. Okay, so let me pull up, and I'm going to send this to you in the chat also, a link to this, but I'm going to put it up in our work document here. So I put together this exponent table list that I feel like represents the ones that you need to know quickly. So if I were to ask you, Craig, if I were to say, hey, like, what is 7 times 8? You know that is, what is 7 times 8?
56.
56. So the speed at which you know that is the speed at which I want you to know these numbers in this table. Like I always say it goes like this, like you need to be able to roll out of bed and say 4 to the 5th is 1024. And the reason is that you need to develop speed for these exams. You need to know that 6 to the power of 3 is 216. So any in these lists, I feel like are kind of the ones that you need to know. And so the reason I asked you about 2 to the 6th is because this is the one that I like to remember. I know that it's 64, and I can generally offset from it. Like if I need 2 to the 7th, I remember, oh yeah, that's 64, so it's double it, it's 128. Another one that programmers like is 2 to the 10th because it's got a 10 in the number value. So we're going to use this in the problem today. There's a lot of uses from this table, so that's why I brought it up here. So let's take a look at the question of the week. Sorry, just grabbing the snip. So I post this question every week on my website. So if we ever don't meet for a week, feel free to go grab it and try it out. And there's a solution there as well. So, all right, so let's take a look at it. When you look at this question, I want you to first read it to yourself. Don't solve it. Let's talk about it a little bit. But go ahead and read it to yourself, please, and then we'll talk.
Okay. Okay.
Okay, so have you read through the problem?
Yeah, pretty confusing.
Yeah. Okay, so I'm going to read it out loud. At a recent annual meeting, a waste company reviewed their policy on radioactive material disposal. Angela, an engineer who works at the company, found that the ratio of radioactive material to non-radioactive material, P, is approximated by the formula P equals G parentheses 2 to the power of minus 10 divided by minus T divided by 10, where G is the ratio of radioactive material to non-radioactive material initially present, and T is the number of years since the year 2016. If G equals 1, how much does the ratio P decrease from the year 2036 to 2056? So there's quite a bit here, the problem is made much simpler by this piece of information here. So if it were me as a student and I could go back in time, I would do things like circle variables, and I know you don't have this in front of you to do, underline. I would do some things to kind of draw attention to the stuff that might be useful there.
Okay.
All right, so I'm going to help you work through this problem. When the year is 2036, okay, this corresponds to a T value equal to 2036 minus 216. Because T in our equation, T is the number of years since the year 2016.
Mhm.
So this means that T is 20, big T is 20. Do you see that?
Yeah.
2036 minus 2016 is 20. And you know how to do that. That's not so hard. So P is G, but what's the value of G? 1 times 2. What's the value of T? 20 over 10. So this is really, it's really just 1 times 2 to the power of negative 2. Now, have you ever seen negative exponents?
No.
Okay. There's a bit more to it, but we'll do a shortcut here. What you do is you write 1 over 2 to the power of 2. So this negative creates this fraction here, but you move this 2 to the bottom and then this exponent 2 also to the bottom. So what is 1 over 2 squared?
1 over.
What is 2 squared?
8.
Say that again.
8.
2 squared means just 2 times 2.
Okay.
It's just 4. Okay, so now we're going to repeat here. We're going to do it for the year is 2056. So T is 2056 minus 2016.
40.
40. And so P is our formula again, it's G, which is 1, 2 to the power of minus 40 over 10, which is 1 times 2 to the minus 4 power, because 40 divided by 10 is minus 4. And so you flip this number, so it's 1 over 2 to the power of 4. What is 1 over 2 to the power of 4?
8.
So it's four twos, right? 2 times 2 times 2 times 2, which is
16.
16. So we ask how much does it decrease from the year 2036 to 2056? So it's 1/4 minus 1 over 16.
Okay. Well, at what grade level is that question level?
Well, I mean, let's look at all the, don't worry about the words. Let's look at all the things that are in here. Are you able to subtract? Of course. Are you able to evaluate a function? Are you able to put numbers into a function? Yes. Are you able to evaluate exponents? Well, maybe once I told you what to do with the negative. Are you able to repeat the information? Absolutely. And then are you able to subtract fractions?
Yeah.
You can do all this. Now, what may be difficult And I'm guessing that's the source of your question is you're asked to do a lot in one question.
Mhm.
And so that's what the challenging part is. The challenging part is you have to do all of this to get the right answer.
Yeah, well, it's just so long.
Right. So the more math you take, the more that there will be problems like this that require a significant amount of effort to be able to do them.
Okay. So, like, do you think on a scale of 1 to 10, how much harder do you think 7th grade year is than 6th grade?
Well, the thing is when you go up in grade level, you know more and you're faster. So while like it does get harder, you're supposed to be a better student to be able to handle it each time.
Okay.
And you're also on a track where you're working on pre-algebra to algebra 1 type stuff.
What level is that?
Well, you can actually take that at any time. I mean, you can start taking pre-algebra when you already have been. So, but before we do another one of these problems, let me just try to show you that what all I'm really asking you to do in these problems is let me pull up a some more problems here, but just from my side here, because I want you to see that you know how to do all this. You just maybe don't feel comfortable yet doing it. Okay. Okay. So let's do this. What is 7 to the -1 power minus 7 to the -3 power?
Okay, so 7
So
to
whenever it's
1 power.
yeah,
That's just -7, right?
no, it's 1/7. Whenever you have a negative exponent, it turns this into a fraction.
Okay. Isn't that the same thing as -7 though?
No, negative. So let's look at a number line here. Okay, here is 0. If I go 1, 2, 3, 4, 5, 6, 7, there's 7. And if I go the other 1, 2, 3, 4, 5, 6, 7, that's -7. Well, 1/7 is like right there. They're not the same. They're not the same. So there's the property we're using here is that if you have a negative exponent, like -3, okay, you write the fraction, but this -3 becomes a +3 and it goes to the bottom.
Because at the bottom is like a negative, right?
Well, the negative, the subtraction comes from here.
Okay. Can we do another one like that?
Well, we got to keep going here. We're not done.
Okay.
So what is 7? What is 7 to the power of 3? And if you're not sure, grab that exponent table I sent you through the chat, and it'll be on there.
Let me check. To the power. Okay. Number 7 to the power 3. Oh, 49.
Are you're looking at the table that I sent you, or something else?
Oh no. 343.
343. Yeah. So this is 1/7 minus 1/343. Now this is where I think I can offer some help to make this faster. You need a common denominator to be able to subtract these. Okay. 7 times 7 times another 7 gets you to 343. So do you see that you have to multiply both the top and the bottom by 49?
Yeah.
So that means 49 goes up here minus 1, which is 48 over 343.
Cause well, why not 49 over 343?
It is 49 over 343 minus 1 over 343.
Okay,
You
okay,
subtract the numerators.
okay.
Okay, so let's try another one here. Let's go 6 to the minus 1 minus 6 to the minus 3.
Okay.
So 6 to the minus 1 becomes 1 over 6 to the power of 1. You don't have to write that 1, but you can.
And then 6 to the power of -3 is 1 over, okay. But do you have to write the 3?
You do, because the rule is if you have a negative exponent, it moves to the bottom. See how this negative n moves to the bottom? -3 moves to +3 on the bottom.
Yes.
So what is 6 to the power of 3 according to your exponent table?
18.
Are you looking at the exponent table?
Uh,
You got to look at it. So these are really important, because 6 to the power of 3 means 6 times 6 times 6.
oh, 216.
Very good. Okay, now what is our common denominator going to be?
216.
216. How do you go from 6 to 216? Well, you notice in that table, the table jumps from 6 to 36 to 216. Sorry. What happens each time? You're multiplying by 6. So you're multiplying this number, this 1 here, by 36. Do you see that?
Yeah.
So what does this become?
Becomes 35 over 216.
Good, good. Okay, so let me give you a slightly different problem, but I want you to tackle this one on your own, okay? Let me just not do that quite yet. Let me okay. Go ahead and try this one on your own, please.
Okay. Okay.
All right. So do you have a final answer for me?
1 over 2 minus -7 over 2.
Like this?
Yeah.
Okay, but let's look back, Craig, because we didn't do that in any of the other problems here. Did I ever put a number other than 1 in the numerator?
No.
So see, 1's in the numerator. How about here? 1 is in the numerator. Let's go back to this one. 1 is in the numerator. Okay, so the right here, this is a problem. What this says is you put a 1 in the numerator, 2, and then a 7 here.
Okay. And then the other one. Wait, but the other one's okay, right?
Yeah, this is correct because it's power of 1 there. See, this 1 becomes that 1, this 7 becomes that 7 there.
Okay. Can we do another one?
Well, no, you got to keep going. What is 2 to the power of 7?
Let me try and write this one out. 128.
Okay, good. So now I want you to subtract these. So you've got to find a common denominator.
Okay. Okay, I got it.
What goes in
think I
the
got
what goes in the numerator over here on the left?
64.
Okay, so what's your final answer?
63 over 128.
Okay, so just to be clear, Craig, when I gave you this problem up here, this is what I'm looking for. This is the I'm asking you to go through all the steps here to get to this final answer. Okay,
Okay.
so let's try another one here. Let's go 4 to the minus 1 minus 4 to the minus 5.
Okay. Okay. I think I got an answer.
Okay,
Actually,
go ahead if you need more time. I'd rather you work it out correctly than not.
okay. Okay. Now I think I got it.
All right, so let me work it out here in case you want to look at this later. So 4 to the 5th is the one that you have to know. That's 1024. Okay. And the next thing is you got to make a common denominator. So you got to like figure out, well, what did I multiply by to get to that? Or you can divide, like you can come over here to the side and be like, all right, but it actually, believe it or not, you can also get it from this exponents. We'll talk about that in a moment. So the answer here is 256 minus 1024. So you get 255 over 1024. Is that the answer you got?
No.
where is your mistake? Is it in line 1, line 2, line 3? Where do you see that you are different from me?
1, because I did, I put 4 times 4 is 8 by accident instead of 16.
Okay, you got to use that table until you, like, the way you learn multiplication, I'm almost sure, is you use flashcards or you had a table you looked at. It's the same way here.
Okay.
Okay, let's try another one here. I got to get you to be able to work through one of these on your own, because I really, this skill, whether it's in this question or another one, this skill is going to come up again. So we got to be really comfortable with it. So let's do this. Let's go 8 to the -1 minus 8 to the -3. Go ahead and give that a try, please.
Okay. The chart is missing 8 for the third power.
Okay, let me take a look here. I'm pretty sure it's got it here. So let me, maybe that was the issue, is it was unclear how to use the chart. So let me snip it in here. And the way you use this chart is the exponent is on the left here. So you either go to the base, in this case 8. This is 8 to the 0. See how there's a 0 there on the left. This is 8 to the 1. This is 8 squared, 8 cubed. So it is there on the chart. Now, if you were looking down here, it obviously wouldn't be there, but it's under the 8.
Okay.
How are you doing on this one?
Okay.
So this is 1 over 8 minus 1 over 8 cubed. 8 cubed is 512 from our chart. You can see that. And so now you've got to make a common denominator.
Yes. 512, right?
Say that again. Yes, the common denominator is 512.
So I think I got it. I think it's 64 over 512 equals 1.
Subtract. We're subtracting.
Minus 1 over 512, and then 63 over 512.
Yes. Okay. Let's see if you can do one all the way through here. And this will probably be our last problem today. I can sense that maybe you're a little bit tired, to be expected from all the school you've been doing over the years. So let's go back here. Let's go, let's go 3, 5. Let's go 5 to the -1 minus 5 to the 4th, -4, sorry.
Okay. 5 minus power of -1, 4.
How are you doing on this one?
I'm pretty good, I think.
Okay.
Is 5 to the power of 1 just 5?
Yeah, anything in the power of 1 is just 5. That's right.
Okay. Well, it's just itself.
Yes. So actually any number to the power of 1 is itself. That's another property. And any number to the power of 0 is 1 is also another property that we might use at some point.
Okay. Is it 1 over 2,500 minus 5 over 2,500?
If 5 to the 4th is 625. Five to the 4th equals 625.
Okay.
So our common denominator is 625.
I think I did it. One more. I did, because 2,500
Yeah.
is that time.
right? So sometimes tables index at 0 instead of 1.
What? Could you say that again?
Sometimes if I go back up to this table, it actually indexes. That's a programming term. It indexes at 0 instead of 1. Like you're used to lists starting at 1, but they can actually start at 0. And so that's maybe
Okay.
something new that you haven't seen before.
Yeah. I didn't know that.
All right. Well, that does take us to the end of our lesson for today, Craig. Glad we got to work through some problems. I've learned a little bit more about you and how to best help you today. I think we're going to do a little bit more looking at tables, but I appreciate you scheduling. And I guess we got a lesson next week, so we'll keep working on
Okay.
everything. All right. Hope you have a great day.
Thank you.
You're
You
welcome.
too.
Bye now.
Bye.